Welcome to Chillin' 101. We hope this video helps.
You already have the surface or two-direction vectors. Start now by writing them in component form. For example, A1, A2, A3, and B1, B2, B3. Once done, make sure the vectors are not parallel because parallel inputs give zero normals, so check quickly by testing proportionality. You do this because the normal must be perpendicular to the surface. Next, align your notation. Label the first vector U and the second V, which simplifies the cross-product step that follows. Now compute U cross V to get the normal. You set up the determinant with unit vectors I, J, K, and the components of U then V. Expand carefully, using signs. I times U2 asterisk V3 U3 asterisk V2 minus J times U1 asterisk V3 U3 asterisk V1 plus K times U1 asterisk V2 U2 asterisk V1. Take your time with signs and parentheses, because a small sign error flips the normal. Once calculated, simplify each component and factor out. Finally, normalize the vector if a unit normal is required. Compute its magnitude and divide each component. Do this because many applications need unit length. Then verify. Dot the normal with each original vector. You should get 0 or numerical noise close to 0. If you don't, make sure to recheck sign conventions, expansion order, and that your original vectors were correctly entered. Order matters for orientation, but not for perpendicularity, so correct any arithmetic slip and recompute.
Thanks for watching. Consider subscribing if we helped you.